Okay, practice worksheet 19B, dividing rational expressions. I know I didn't do this the other day, so I'm sending you this video on how to work these problems. So practice worksheet 19B. Number 1, we want to divide. So we have the square root of 5 over 121, right? The square root of 5 over 121. We split it up as the square root of 5 over the square root of 121. You cannot take the square root of 5, so leave it under the radical. So you have the square root of 5 over 11, because the square root of 121 is 11. And this is your answer. Number 2, we have the square root of xy squared over 81. Right? We split it up. We have the square root of xy squared over the square root of 81. Right? We can take the square root of y squared. The square root of y squared is just y, but we're left with that x on the inside. And the square root of 81 is 9. Right? That's your answer for number 2. Number 3, here we have the square root of 54, x to the third, over the square root of 2x. Right? We write this as one fraction. 54, x to the third, over 2x. Right? Simplify the fraction first before taking the square root. So we have the square root of 27, x to the second. Right? Because 54 divided by 2 gives us 27. X to the third divided by x gives us x squared. Subtract your exponents. Remember, the exponent on the x is 1. So 3 minus 1 gives you 2. Now you want to simplify the radical. Your perfect square in 27 is 9. 9 times 3, x squared. Right? Your perfect squares are 9 and x squared. We take the square root of those two. So you end up with 3x, and you're left with the 3 on the inside of the radical. And that is your answer. Okay? So yes, those are nice and simple and everything. Okay? But let's move on to the next one. Rationalizing your denominator, right? When they say rationalize the denominator, right? Meaning no radicals in the denominator. Right? We do not want any radicals in the denominator, so we have to rationalize it, meaning we have to get rid of the radical in the denominator. So you just go back, see number 1, number 2, and number 3, our answers, right? There's no radical in the denominator. There's no radical in the denominator. Right? Here, we don't have anything in the denominator, right? For number 3, okay? So we do not want a radical in the denominator. That's what we want. We do not want a radical in the denominator. Okay, so the first one. Here we have the square root of 5 over the square root of 2, right? So we want to rationalize the denominator. Well, the first question is, you got to find your perfect square. Your perfect square, right? If we say 2 to the second power, that gives us 4. Is 4 perfect? I know all y'all will say, yes, 4 is perfect, right? Yes, 4 is perfect. So to get 4 in your denominator, right, we have to take the square root of 2, top and bottom. Because if you take the square root of 2 and you multiply it by the square root of 2, you get the square root of 4, right? And 4 is a perfect square. But if you do it to the bottom, you got to do it to the top. No matter what you do to the bottom, you got to do the same thing to the top. So now we just multiply like you did on the previous worksheet, multiplying your rational expressions. You multiply square root of 5 times the square root of 2 gives you the square root of 10. The square root of 2 times the square root of 2 gives you the square root of 4, which is what? Yes, 2. Right? And this is your answer. No, 2 cannot go into 10 because 10 is underneath the radical. So if you were talking about 10, right, the square root of 10, if we put in our calculators, right, you get 3.162 over 2. See, 2 can't go into that number. Okay, so 2 cannot go into the square root of 10. So do not do that. You do not want to do that at all. So your answer is the square root of 10 over 2. Okay, the square root of 10 over 2. Okay, so all you're doing is looking for your perfect square, right? So for me, what I would say is, okay, we got the square root of 2. We talking about the square root. So our index is 2. It's understood to be 2. So remember, you're talking about groups of 2. So we have a 2. So we need one more 2 to make a group of 2, right? So we have 4 underneath the radical. So you take the square root of 4, which gives you 2. Let's do the second one. Okay, so here we have 5 over 18. So we have the square root of 5 over the square root of 18. Always simplify your radical, right? You always want to simplify your radical. So your perfect square in 18 is 9. And 9 times 2, right, gives you 18. The square root of 9 is 3. So we have 3 square root of 2. Okay, so again, you have a square root of 2 in your denominator. That means you're going to multiply top and bottom by the square root of 2, because that's going to give you the square root of 4, and we all know that's 2. So we have the square root of 10 over 3 times the square root of 4, right? So we have the square root of 10 over 3 times 2, and the square root of 10 gives us square root of 10 over 6. Right, we have the square root of 10 over 6. Okay. Now, some people, they may go, instead of doing what we did above, we have the square root of 5 over the square root of 18. Right? And you would say, okay, the square root of 18 over the square root of 18, because you just want to double it. Since you're talking about square root, right? So we have to have 2 of them. So we have 5 times 18 gives us 90. So we have the square root of 90 over, right, the square root of 18 squared. I don't know what it is. You can put in your calculator and find out. Right? So we have the square root of 90 over 18, because the square and the square root will cancel each other out. Okay? Or if you do 18 times 18, right, you get 324. Okay, and you take the square root of 324, you get 18. Okay, now, your perfect square in 90 is 9. So we have 9 times 10 over 18. The square root of 9 is 3. So we have 3 over 10 over 18. 3 goes into 18 6 times. So our answer still comes out to be the square root of 10 over 6. Right, and that's our answer, the square root of 10 over 6. Okay. Next one. We have number 3. Now we're looking for the cube root. So what does that mean? That means we're looking for a triple. Right? Instead of a square, we're looking for a triple. So, okay, let's do the triple. So we multiply by 2, right? And we multiply by 2 more of these, right? Because now we have our triple. Woohoo! Okay? So that means we have, wrong color. That means we have the cube root, right? 3 times 2 is 6. 6 times 2 is 12. Over the cube root of 8, which gives us the cube root of 12 over 2. Right? And again, 2 cannot go into 12 because that's underneath the radical. That 12 is underneath the radical, so 2 cannot go into 12. So do not do that. That is your answer. Okay? Let's do number 4. So here we have the square root of x plus 3 over the square root of x minus 2. X plus 2. Right? The square root of x minus 3, x plus 3 over the square root of x plus 2. Okay? So, to do this, right, same principle. You got the square root of x plus 2, multiply top and bottom by the square root of x plus 2. Right? Multiply top and bottom by the square root of x plus 2. Do not fold that bottom out. your answer for the bottom will be x plus 2. Because if you notice, when we dealt with, going back, right, the square root of 2, right, and the square root of 2, it gave us 2. Same principle. So when we come over here, we have x plus 2 times x plus 2, and you're taking the square root, you get x plus 2. The top, you got to do your full method, right? So you have x squared plus 2x plus 3x plus 6, right? Combine your like terms, so you end up with x squared plus 5x plus 6 over x plus 2, and that is your answer, right? And no, you cannot take the square root of x squared, right? Because you got that plus, right? You got these pluses inside. If you have pluses, you cannot take the square root of x squared. It has to be multiplication in order for you to take the square root, right? All of it has to be multiplication in order for you to take the square root. Okay, so I added a couple of more so we can grasp it. Okay, so if I want the square root of 4 over 5, right? Remember, this is the square root of 4 over the square root of 5. Extend it out. We need a group of 2. So multiply the bottom by 5. Ooh, look, we got a group of 2 now. Multiply the top by 5. So you have the square root of 20 over, oh, I shouldn't even use that. Never mind. Let's go back because, of course, the square root of 4 is 2. So we want to make one that's now easy to simplify. Okay? So let's go back. We have the square root of 3 over 5, right? So we have the square root of 3 over the square root of 5. Okay, so extend your radical, multiply the bottom by 5. Extend your radical, multiply the top by 5, right? You want a group of 2. So we have 5 times 5 gives us a group of 2. So we have square root of 15 over the square root of 25. I know most of you now know that it's going to be 5, but I like to write it out for those who need to see it. So we have the square root of 15 over 5. And that's our answer. Let's do another one. Here we have the cube root of 4 over 5, right? So we have the cube root of 4 over the cube root of 5, right? Now this one we're looking for perfect cube. So we need 3 5s. So we need 2 more, right? So we do 2 more. So the top, we have the cube root of 100 over the cube root of 125, and the cube root of 125, of course, is 5. Right, so that is your answer. Okay, one more. The cube root of 6 over 7, right? So we have the cube root of 6 over the cube root of 7. We're looking for 3, right? So we need 2 more of 7s, 2 more 7s at the top. So we have the cube root, and I don't know what that is, but we're going to do it. We have 7 times 7 times 6 gives us 294 over the cube root. 7 times 7 times 7 gives us 343, right? For those who need to see the big number, the cube root of 294 over 7, because the cube root of 343 is 7. And that's your answer. I hope that helped for rationalizing the denominator. Now, let's move on to the next one. Right, we want to multiply conjugates. So if I have a plus b, the conjugate of that, we all know, would be a minus b. It's all the time and every time, no matter what. So if I have x plus 2, the conjugate of that would be x minus 2. So if I have the square root of x plus 3, the conjugate of that would be the square root of x minus 3, right? So sometimes they give us the minus, sometimes they give us the plus. Whichever one they give us, we always got to get the opposite sign. Okay, so let's multiply these. Okay, the first one we have on our notes is the square root of x plus 2. times the square root of x minus 2, right? Do your fold method, right? So you have the square root of x times the square root of x, right? Gives you the square root of x squared, right? Then you do your outer, you get negative 2 square root of x. You do your inner, you get positive 2 square root of x. And then you do your last, you get negative 4, right? So this ends up to be x. These cancel out, and you have minus 4. So your answer is x minus 4. Makes sense because when you do this, you have a squared minus b squared. It will always be that. A squared minus b squared. So it's always going to be two terms, x minus 4, right? So the second one, we have the square root of 6 plus 3 times the square root of 6 minus 3, right? So if we just go by the formula, square root of 6 times the square root of 6, right, just gives us 6, okay? And then 3 times negative 3 gives us negative 9, so our answer is negative 3, okay? Now, for those who need to see the actual work, that's no problem. Let's see the actual work, right? The square root of 6 times the square root of 6 is the square root of 36, right? That's your first. Your outer, you get negative 3 square root of 6. Your inner, you get positive 3 square root of 6. And your last, you get negative 9, right? The square root of 36 gives us 6. The inner and outer terms cancel out, minus 9. So again, you end up with negative 3. Okay? Moving on to the next one. Now we talk about rationalizing the denominator. So this is where the conjugates come into play. Okay? So we want to rationalize the denominator. So say, for instance, I have 1 over x minus 2, right? The square root of x minus 2. Well, let's not do that one because we already have that one as one of our examples. So if I have the square root of x minus 3, so I want to multiply top and bottom by the square root of x plus 3 when we want to rationalize our denominator. So we have the square root of x plus 3 because you're multiplying the 1 and the 3. And here we have the square root of x times the square root of x gives us x. Negative 3 times 3 gives us negative 9. So this would be your answer. Of course, I would go a little bit slower, not slower, but I would go into depth if I was to do my full method for those who need to see it. But we have 2 examples where I will do that. Okay, so for number 1, we have 2 over 2 square root of 2 plus the square root of 3. So since you have a plus, we want a minus. So we multiply, right? We will multiply top and bottom by 2 square root of 2 minus the square root of 3. Okay? Now, what you're going to do is multiply your top and multiply your bottom. So 2 times 2 square root of 2. Let's do it this way. Right, 2 times 2 square root of 2 gives us 4 square root of 2. And then 2 times the square root of 3 gives us minus 2 square root of 3 over, and I did it in different colors, but that's okay, over, we do our full method. 2 square root of 2 times 2 square root of 2, right? You multiply your outer just like you did the multiplication paper, okay? Same principle here. So you multiply the 2 and the 2, you get 4, right? And the square root of 4, because square root of 2 times square root of 2 is the square root of 4, right? Then you do your outer. You have minus 2 square root of 6. Then you do your inner. You get plus 2 square root of 6, right? And then you do your last, minus the square root of 9, okay? Then we have 4 square root of 2 minus 2 square root of 3 all over 4 times 2, right? Because the square root of 4 is 2, right? Inners, outers cancel, minus 3. So we have 4 square root of 2 minus 2 square root of 3 over 8 minus 3, which is, so you have 4 square root of 2 minus 2 square root of 3 over 5, and that's your answer. And the last one that we have, now of course before I go into that, if this was a 2, right, then you would have to say 4 square root of 2 minus 2 square root of 3 over 2, divide the 2 into both of these. So your answer would have been 2 square root of 2 minus the square root of 3. Right, 2 square root of 2 minus the square root of 3. That would have been your answer if the 5 was a 2, right? If the 5 was a 2. Okay, and the next one, the last one, we have the square root of x plus 3 over the square root of x minus 2. Me, personally, I would pause it, try to do it yourself first to see if you get the right answer, okay? But if you don't want to pause it, that's fine, right? So we have the square root of x plus 2, top and bottom. Do your full method for your top, do your full method for your bottom. So you have the square root of x times the square root of x gives you the square root of x squared. The square root of x times 2 gives you 2 square root of x. 3 times the square root of x is just 3 square root of x. And 3 times 2 gives you 6. Over. The square root of x times the square root of x is the square root of x squared. 2 square root of x and negative 2 square root of x cancel out. But if you have to write it out. 2 square root of x minus 2 square root of x. Negative 2 times 2 gives you a negative 4. So you have x, combine your like terms, plus 5 square root of x plus 6 all over x, right? The square root of x squared is x. The inners and outers cancel out, so like I said before, minus 4. No more radicals in your denominator. And that's what they mean by rationalize your denominator. It does not matter about your top. It just matters about your bottom when you're talking about rationalizing your denominator, right? Getting rid of the radical in your denominator. So if you listen to this video and you turn in your paper on Tuesday, right, I will double your points on your worksheet, right, if you turn it in on Tuesday, right? So double points on 19B, right? Practice worksheet 19B if turn in on Tuesday. And yes, I'm going to put the date too. Tuesday, September, let's see, today's 17th, 2019. Okay, so try it out, see what you do, and we'll talk on Tuesday.